Okay, so we are spending another day on factoring trinomials where we have to use the method slip and slide. The only time we have to use the method slip and slide is whenever there is not a there is a GCF, but I still have a value in the leading coefficient position, okay? That's when you use slip and slide. So remember, slip and slide, the slip, you slip the a value, which is that beginning term, to the end of the trinomial and multiply by the c value. So then it becomes a basic trinomial, and then we work the factoring trinomial like we've done before. So let's go over several examples. Number one, so there is not a GCF. We always check for that first. Since there isn't one, but I still have a value out in front, we're going to slip the value to the end. So it becomes x squared plus 5x. 2 times 2 is positive 4. Then it becomes a basic trinomial, which I then want to break up into two binomials. Since c is positive, I know that these are going to be the same. They're either going to be both pluses or both minuses, and the b value tells me what it's going to be, so they're both going to be positives. Then I read this backwards. What two numbers multiply to get 4 but add to get positive 5? Multiplies to get 4 but adds to get positive 5, and the two values that come up are 4 and 1, because 4 times 1 is 4, and then 4 plus 1 is 5. And it doesn't matter where I put the 4 and the 1 because both of these are positive. Now, don't forget, when I do slip and slide, we have to bring back this a value as a denominator. Then I check to see if they simplify. For instance, 4 over 2 simplifies to just 2. 1/2 does not simplify, so it stays. And then here comes the slide part. The slide means I'm going to slide the denominators back to the front. But since this one doesn't have a denominator, it's just x plus 2. This one has a denominator of 2, so I'm going to slide it to the front of the x, so it just becomes 2x plus 1. And I can check my work by foiling this out and seeing if I end up back at the beginning. Number 2, there is no GCF, so I have this value out up front. I'm going to slip to the end. So it becomes n squared plus 5n. 3 times 2 is positive 6. I then am going to break it up into two binomials. Since c is positive, that means they're both going to be positive or both going to be negative. b tells me that they're both going to be positive. Then I read it backwards. What two values multiply to get 6 but add to get 5? And the two that come to mind are 3 and 2. Since 3 and 2 have the same sign, it doesn't matter where I put them. Then I need to bring back my a value and see if I can simplify. For instance, 3 over 3 simplifies to just 1. 2 over 3 does not simplify. Then I'm going to slide my denominators to the front, where this one doesn't have 1, so it's just n plus 1. This one has a denominator of 3, so I'm going to slide it back to the front, 3n plus 2. Over here, number 3, since there is no GCF, I'm going to slip that 2 to the end, so y squared plus 9y, negative 5 times 2 is negative 10. I'm going to break it up into two binomials. So then, since c is negative this time, one's going to be positive, one's going to be negative. What two numbers multiply to get 10 but subtract to get 9? And the two numbers that come up are 10 and 1. Since 10 is the larger value, 10 is going to go with the sign that b is. So since b is positive, 10 has to go with the positive, and 1 has to go with the negative. Then I bring this a value back as a denominator. Here, 10 over 2 simplifies to just 5, and 1/2 does not. Since there is no denominator to bring back, it's just y plus 5 on this first binomial. The denominator here is 2, which I'm going to slide back in front, so it's 2y minus 1. And that's just the same process over and over again. So number 4, there is no GCF. I'm going to slip that 3 to the 2, so g squared minus 7g, 3 times 2 is positive 6. Then I'm going to break it up into two binomials. Since c is positive, that means they're both going to be the same. b tells me that they're both going to be negative. What two numbers multiply to get 6 but add to get 7? And the two that come to mind are 6 and 1. It doesn't matter where I put the 6 and 1 because they're both negatives. I have to bring this 3 back as a denominator. 6 over 3 simplifies to just 2, but 1 over 3 does not. So since there is no denominator here, it's just g minus 2. Since the denominator is 3, I slide it to the front, so it's 3g minus 1. There is no GCF on number 5, but I have to slip that 2 to the end. So it's k squared minus 11k. 15 times 2 is positive 30. I break it up into two binomials. So then C is positive, which means they're both going to be the same. B tells me that they're both going to be negative again. What two numbers multiply to get 30 but add to get 11? And the two numbers that come to mind are 6 and 5. It doesn't matter where I put the 6 and the 5 because they're both negative. And then I bring the 2 back. As a denominator, 6 over 2 simplifies to 3. Since there is not a denominator here, it's just k minus 3. This denominator is 2, which I got to slide back to the front, so it's 2k minus 5. Here there is no GCF, so I'm going to slip that 9 to the 8. So p squared plus 6p minus 72. Break it up into two binomials, so p and p. Since c is negative, that means one's going to be positive, one's going to be negative. And what two numbers multiply to get 72 but subtract to get 6? Let's see. Nope. There we go. The two numbers that are 12 and 6 because 12 times 6 is 72 and 12 minus 6 is 6. Since 12 is the larger number, I have to put it with the value that b is, and since b is positive, I have to put 12 with the positive and 6 has to go with the negative in order for this to work. Then I have to bring this 9 back. Now here, both of them simplify. 12 over 9 simplifies to 4 over 3. 6 over 9 simplifies to 2 over 3. Then I'm going to bring the denominators to the front. So this becomes 3p plus 4. And this becomes 3p minus 2. So that one's a little bit different. Number 7, there is no GCF, so I'm going to slip that 6 to the end. So m squared minus 13m. 6 times 6 is 36. So I'm going to break this up into two binomials. Since c is positive, they're both going to be negative because the b tells me that. What two numbers multiply to get 36 but add to get 13? And if I'm not mistaken, let's see, is 9 and 4. It doesn't matter where I put the 9 and the 4 because they're both negatives here. Then I have to bring the 6 back, and both of them simplify. 9 over 6 simplifies to 3 over 2, and 4 over 6 simplifies to 2 over 3. The denominator slides to the front, so this becomes 2m minus 3, and then the denominator slides to the front, so this becomes 3m minus 2. And it just happens to be a coincidence that it's written that way. Number 8, I'm going to slip that 3 to the 16, so c squared plus 2c, my mind went blank on that one, minus 48, because 16 times 3 is 48. I'm going to break this up into two binomials, and then since c is negative, that means one's going to be plus, one's going to be minus. What multiplies to get 48 but subtracts to get 2 would have to be 8 and 6. Since 8 is the larger value, I have to put it with the sign that b is. So 8 has to be the positive and 6 has to be the negative. I have to bring this 3 back. And the 8 over 3 does not simplify, but 6 over 3 simplifies to just 2. So I bring that denominator to the front. So this is 3c plus 8. And this is just c minus 2 because it does not have a denominator to slide back. Number 9, there is no GCF, so I'm going to slip that 4 to the 9. B squared plus 12b. 9 times 4 is 36. Then I can break this up into two binomials. Since c is positive, they're going to be the same. And since b is positive, that means they're both going to be positives. What multiplies to get 36 but adds to get 12? And the two numbers that come up are 6 and 6. It doesn't matter where I put the 6's, of course, because they're both the same. Then I'm going to bring back that 4 as denominators and simplify where I can. So 6 over 4 simplifies to 3 over 2. 6 over 4 simplifies to 3 over 2. I'm going to slide those denominators back to the front. So this becomes 2b plus 3. And this becomes 2b plus 3. Remember on this one, whenever they end up being the same binomial, you can also see it written as 2b plus 3 squared, which means 2b plus 3 times itself. Now let's go over some whenever we have a GCF, because yes, at first glance, I'm just going to slip that 8 to the 10, but then we're dealing with really, really large numbers, and it's not the simplified version that it could be. So we always have to check for a GCF. For instance, number 10, the GCF of 8, 2, and 10 is 2. So when I bring that 2 out, it makes this a little simpler. 8x squared divided by 2 is 4x squared. Negative 2x divided by 2 is just negative x. And negative 10 divided by 2 is negative 5. So now it's just a little bit simpler of a problem. Now that I have it simplified the most I can, I'm going to slip this 4 to the 5. I have to bring this GCF down. So 2 parentheses x squared minus x, 4 times negative 5 is negative 20. Now I'm going to break this trinomial up into 2 binomials, and I didn't leave myself very much room there. So since c is negative, one's going to be positive, one's going to be negative. What multiplies to get 20 but subtracts to get 1, and the two numbers that come up are 5 and 4. Since 5 is the larger number, it has to go with the sign that b is, so 5 goes with the negative and 4 goes with the positive. But don't forget, we have to slide bring back this 4. Not the 8, because we took the GCF. We have to bring back this 4. So 4 over 4 simplifies to just 1. 5 over 4 does not simplify, so I'm going to write my answer up here. I still have this GCF out in front. So this one is just x plus 1. And then this one, I'm going to slide that denominator back, so it's 4x minus 5 on the second binomial. Okay, so just the same thing, looking for a GCF first. So number 6, the GCF of 6, 9, and 27 would have to be 3. So then 6a squared divided by 3 is 2a squared. 9a divided by 3 is positive 3a. And negative 27 divided by 3 is negative 9. Now I'm going to slide this 2 to the 9, bring down this 3. So it becomes a squared plus 3a, negative 9 times 2 is negative 18. Now I can break this up into 2 binomials. Since c is negative, 1 is going to be positive, 1 is going to be negative. What multiplies to get 18 but subtracts to get 3 would have to be 6 and 3. Since 6 is the larger number, I have to put it with the sign that b is, so 6 has to be the positive and 3 has to be the negative. I have to bring back that 2 that slipped at the beginning, not the 6, but the 2. So I'm going to bring that back as the denominator. 6 over 2 simplifies to 3, and 3 over 2 does not simplify. So I have 3 parentheses. There's no denominator to slide, so a plus 3. This one has a denominator of 2 to slide back to the front, so 2a minus 3. Okay, number 12. The GCF of 60, 4, and 8 would have to be 4. 60x squared divided by 4 is 20... No, sorry. Let's see, that's 1, 15x squared plus x minus 2. Okay, then I can slip that 15 to the end. So I have x squared plus x, negative 2 times 15 is negative 30. Now I can break this up into 2 binomials. So since c is negative, one's positive, one's negative. What multiplies to get 30 but subtracts to get 1 would have to be 6 and 5. Since 6 is the larger number, I have to put it with the sign that b is. So 6 has to be positive and 5 has to be negative. I want to bring back the 15, not the 60, but the 15. So then 6 over 15 simplifies to 2 over 5. 5 over 15 simplifies to 1/3. Both of them have a denominator to slide back to the front, so this 5 goes to the front, so it ends up being 5x plus 2. The 3 slides to the front, so this ends up being 3x minus 1. Okay, number 13. The GCF of 16, 24, and 8 would have to be 8. 16x squared divided by 8 is 2x squared. Negative 24 divided by 8 is negative 3x. And positive 8 divided by 8 is positive 1. They don't cancel out. Now I can slip that 2 to the end. So x squared minus 3x, 2 times 1 is positive 2. I can break this up into 2 binomials. So then since C is positive, that means they're going to be the same. B tells me that they're both going to be negative. What multiplies to get 2 but adds to get 3 would have to be 2 and 1. It doesn't matter where I put the 2 and the 1 because they're both negatives. I have to bring the 2 back, not the 16, but the 2 as my denominator. Here, 2 over 2 simplifies to 1. 1 over 2 does not simplify. So then I just slide my denominators back. This first one doesn't have 1, so it's x minus 1. The second one has a denominator of 2, so it ends up being 2x minus 1. Number 14, 20, 55, and 30 have a GCF of 5. So 20x squared divided by 5 is 4x squared, 55x divided by 5 is 11x, and 30 divided by 5 is 6. Now I can slip that 4 to the end. So x squared plus 11x, 4 times 6 is 24. And then I break this up into two binomials. Since C is positive, that means they're both going to be positive or both going to be negative. B tells me that they're both going to be positive. What multiplies to get 24 but adds to get 11? And the two numbers that come to mind are 8 and 3. It doesn't matter where I put the 8 and the 3 because they're both positive. I have to bring the 4 back, not the 20, but the 4. So 8 over 4 simplifies to 2, and 3 over 4 does not simplify. So then I'm going to slide my denominators back. This one does not have a denominator, so it's just x plus 2. And then this one has a denominator of 4, so it's 4x plus 3. Last but not least, 15, 10, 32, and 24 have a GCF of 2. 10x squared divided by 2 is 5x squared. Negative 32x divided by 2 is negative 16x. And positive 24 divided by 2 is positive 12. Then I slide this 50 to the end, or this 5, sorry. Slip the 5 to the end, so it becomes x squared minus 16x. 12 times 5 is 50. That's where I got the 50 from. Nope, 60. Wow. 12 times 5 is 60. Make it to the end, and then I mess up. So then I break this up into two binomials. Since C is positive, that means they're both going to be positive or both going to be negative. B tells me that they're both going to be negative. Well, it multiplies to get 60, but adds to get 16. And the two that do are 10 and 6. It doesn't matter where I put the 10 and the 6 because they're both negative. Then I have to bring the 5 back, not the 10, but the 5. 10 over 5 simplifies to 2. 6 over 5 does not simplify, so then I'm going to slide my denominators back. This first one does not have a denominator, so it's x minus 2. The second one has a denominator of 5 that slides back to the front, and it's 5x minus 6.